to start, so you'll hear that, I call it fraction exponents. Sometimes you'll see this called rational exponents, which would include all rational numbers, decimals, right, integers. Everything's game with a rational exponent. And I'm going to teach you what this does, and you can write this somewhere on that little PDF you got today. I will teach you what this does by using something you already know. You know, I like doing that. So here is an example of a rational exponent. Something like 9 to the 1/2 power. Okay, 9 to the 1/2 power. Now let's use like we just went over the properties, review. What's a property I could use to get my 1/2 power to go away? Tan, you got an idea? Right here I got a 1/2 power. How could I get that 1/2 power to be a 1? Because 9 to the 1 would be 9. No, that wouldn't help me. That just means reciprocal, right? That would flip it. But how can I get my 1/2 to become a 1 using a property? What?
Multiply by the reciprocal, multiply by 2.
Multiply, so, okay.
In this case by 2, but it would be by the reciprocal.
Raise it to a power of 2, which would,
multiply by the reciprocal exponent.
Yeah. So we all agree that 9 to the 1/2 to the second power, we've got the power rule happening. We can multiply, and this would be 9 to the first, which is 9. Can we all follow that? Like, even if you don't know what's going on with the 1/2 power, can we follow that 9 to the 1/2 squared has to be 9 to the first?
Yes, sir.
Okay. So, remember back to the Pythagorean theorem next. If I had a square root of something, how did I undo that square root? What operation undoes the square root of something?
Square.
Square it, right? So the square root of 9 squared was 9.
Yeah.
Check this out. So looking here, what must be true about the 1/2 power and the square root of 9?
They're the same.
They're the same.
That's crazy.
Right? So I want to show you one other thing that's going to be a little crazy. If we had something like 8 to the 1/3 power, that's the same as the cube root of 8.
No.
So let's talk about square root. Square something times itself to equal that. Cube root would be something times itself times itself. It's inverse of cubing. If you cube it, there's 3 factors of it.
And if you square it, there's 2 factors.
Well, this is the cube root. If you root it, 3 of the same factors. So this would be 2, 4, 8. So, the reason this works is, if you were to cube it, that's 8. If you were to cube the cubed root, that also equals
8, because it would have to be 2 times 2 times 2.
So could you do to the 4th power root?
there's a root that undoes every exponent. Good question. So like, let's say it's 3 to the 256th. I can undo that with the 256th root.
So you can do a root to any number.
The root is the inverse operation. You know, like there's add, subtract, multiply, divide, exponents, roots. And you might remember that when I taught you the order of operations, I wrote here exponents / roots.
You did.
And I was like, you only have square roots right now, but there's infinite roots, right? So the roots are undoing the exponents. Now, we got another thing we need to look at, though. And maybe we should just go to your PDF, one from your PDF. You guys like to do an example right on there?
Yeah, sure.
I want to check out number 4 with you on there. So we're to extend this.
4 is likely 7 and 4
Okay. So if we had like a half and a third, what number was telling us the root in those fractions? The numerator or denominator? Yeah, so for example, we had 4 to the 1/2.
Yeah.
We said that means square root of 4, right? But square root of 4 is actually to the
second power.
first power still. It's the square root.
So it's a
So,
numerator.
for 7 to the 4/3, we have the power in the numerator, It was there in the 1/2. It was just the first power. Okay. And we have the root in the denominator. Which means if we want to write this in what's called radical form, it's radical, dude.
Radical.
We're going to write it as the cubed root of 7 to the 4th power. These are the same. This is exponential form. This is radical form. Radical form often is a little easier to simplify if we were to get like a number answer. We would take the cubed root of 7, raise it to the 4th. Cubed root of 7 is ugly, by the way. Don't do it. It's going to be an ugly number. And I will teach you later how to do this in a calculator. There are, like, you can do all the roots in your calculator if you have the right calculator. Joe.
So for the homework, could we just write the radical form as an answer?
It depends what the directions are. So if it says write it in radical form, yes.
It doesn't tell
If
you
it
that
says
at home.
if it says that, that's right there.
It doesn't say
If it
that.
said simplify, if there's other things to simplify, you'd have to do it. So you'd try to take the cube root. I want you on that homework PDF to try numbers 2 and 6.
That's homework.
No. 2 is 4 to the 4/3. 6 on there is 2 to the 1/6. I want you to try to write those in radical form for me, please. So, for 4 to the 4/3, my root is 3. So I have cubed root of 4. And my exponent is 1.
I don't get how, like, I got it right, I just don't get how it's meant.
It's just, math is, it's the symbol aspect, the communication symbol.
I know, like.
There is an answer to this, we're just not focused on that yet.
So easy.
Okay, so 2 to the 1/6 power is the 6th root of 2. Now, you could write it to the 1st power, but guess what?
No.
It's just itself, so.
Yep.
So what I want you to attempt next is to try to do the other way. So number 10. Let's do number 7 and number 10 on the next section. Square root of 10 to the 3rd. And number 10, which is 4th root of 5 to the 5th. I want you to try to write those in exponential form. So as a base to an exponent. So, if my base is 10, what's my exponent part? 3. And it's the square root. So 10 to the 3/2. You might also see this as 10 to the 1.5, just the same thing.
That would be a little off though. I feel like it would be more simple to use fractions.
What part, Tanian? The exponent's 3, the root is a square root. So the top is going to be our exponent.
Oh, that makes sense.
Okay, looking at number 10, my base is 5. It's to the 5/4 power.
Or the 1.25.
You could see a 1.25 there too. But
Fraction.
I don't really mess
Fraction's
with that.
easier.
I
We don't
really
mess with that.
I agree.
You can't, just if you see it, just know 1.25 is 1 1/4, which is 5/4.
I agree, Mikey.
Cool.
Easier to
Now,
use fractions.
what do you guys notice about number 13 on
It
that?
has X.
It has an X, so that's no big deal though. And what else do you notice?
Negative exponent.
Yeah.
Also, no big deal, because what does negative exponent mean? You guys just told me
Flap
about
it.
it.
Flop it.
Flap it.
Flipped.
Reciprocal.
Means reciprocal, right? So, this would be the same thing as, I'm not done,
Well,
but these are the same, right?
Yes.
I'm not done, but these are the same, because it's asking me to write it in radical form. Well, to write in radical form, I need the 4th root of 5x, and it needs to be raised to the 5th power. The only thing different here is there's a negative. So if it's negative, it's got to be reciprocal. That's it.
Okay, so basically everything's normal.
Except
just
it's
put
in
a
the
1 over it.
Kinda. I don't want you to generalize, like just put a 1 in it. I want you to understand that's the reciprocal, because if I gave you something like 1 over 5x to the negative 5/4, all right, that would be
That would be
4th root of 5x to the 5th. Straight up, right?
yeah, because reciprocal. You
Reciprocal. So I just want,
weight of it.
yeah, I just want you to understand reciprocal means you gotta do the reciprocal. All right, flip it over.
Is this stuff?
We're gonna do it the other way there too, number 24.
Oh, we've been doing this on the paper? I've been doing it on my blank piece of paper.
Okay.
Oh my gosh, should I write it down on the paper?
Wherever you're gonna be able to remember to keep it, I would say.
Is this whole page going to be homework?
So let's check this one out. So if I'm going to write this in exponential form, I want base to an exponent. So what is my base?
3K.
3K. All right,
3,000.
3K. Now, let's work on next to get my fraction to flip, to get it up in the numerator like this. Is my fraction going to be positive or negative?
It's a negative.
Negative. What's the exponent on my fraction?
It's either 2 over 5 or 5 over 2.
It's 5 because it's to the fifth power,
Oh, yeah.
and it's over 2 because this is a square root.
But then when
I knew it was 5.
So this would be the exponential form. Okay? Cool. One more thing to do.
And then is the whole page.
See where it says simplify? Let's look at number 26 and 32 together. You're probably going to want to use a calculator.
number 3
Okay? So what I do on this one is, I start by going right here first. I do my cubed root of 343 to the 4th power. In your calculator, most of you, your calculator, I might have to work with some of you, but wherever the exponent button is, you know that little caret that looks like that?
Oh, yeah,
Caret?
that's
If you hit second, so that's like the exponent button. If you hit the second button, then this, usually that'll give you a root. You might have to put your number in first. So like on this one, if I want the third root, in your calculator, you're probably going to push 3, second caret, 343.
Wait,
What do you mean by
This is
second?
not a nice number.
So you have to get like a second, you took the square root of it. So you'd have to say like third, the second, then caret button will give you the root, which would be third root. It's got an X with the root. The button that is like printed in the other color will look like this.
I can't do it as a fraction.
Show me your calculator. Okay, Mikey, that's the issue.
Okay, how do I do this?
So, most calculators, it's going to work like this. If not, I'll work with you on it. Mikey, I can help you on your calculator, not your computer, because your computer is a computer. Right? I'll help you on yours as well. Yours might be different.
Thanks.
So,
What second?
I don't have my calculator.
the second caret is like wherever you see the caret button, right? Because the calculator's buttons do multiple things.
Yeah, I see the carrot.
Okay, if you hit second, that button, it does the thing in the other print. Do you see it? Second
Oh,
button.
at the top left.
Yeah, second.
I'm-
It's like a shift button on a
I
computer.
have a Texas calculator.
Oh, yeah, it didn't
Yeah, I can look at it with you.
I don't have it.
Okay. So if you do that, the cubed root of 343
Something.
is what? 7.
73.
Which means 1 over 7 to the 4th, which is 1 over 2,401. So I'll work with you if you're having trouble on the calculator getting that to work. What's cool is the calculator has organization. Whatever the square it button is, the root is the inverse. It's like kind of cool. That's set up as the inverse. So you have to put the number of your root first. If it's square root, there's a dedicated square root button. Okay? But if you have to do any other root, you have to put the number of your root first. Number 32. I've got 81. M to the 6th to the 1/2. What gets raised to the 1/2 power, friends? Everything. So I like this step first. Everybody follow that?
No.
81 to the 1/2 hour. I can do 6 to the 1/2, which is 3, because I can multiply.
1/2 is 9.
So 81 to the 1/2 is the same thing as square root of 81, right?
Which is
9.
9.
So as I go
9
about,
to the third.
so notice the directions on these say, it says simplify. So that's going to be like, if you can get a number, get a number.
So 9 and 3 is the final answer?
Yeah, 9m to the 3rd.
So you would not
Yeah.
multiply 9m cube. You would not cube 9m to get whatever that is.
No, because only m's
You
cubed.
don't know.
Because they are not
They're not magically.
magically
Yeah.
attached. All right.
Yep.
Homework's the odds. Let's go.